Hello and welcome to a brand new video tutorial in LightWave. In this tutorial, we gonna be creating this scene here. It's a bubbly sphere, runs into the center and colliding each other in a bubbly way. This scene type here, I create in every other 3D application that I use to testing out a very basic, simple setup. It's a kind of a benchmark to figure it out how the dynamic system works, okay? And in this tutorial, we do this in LightWave. So let's get started. All right, so here we are in LightWave layout. We start right away in LightWave layout to create the spheres and the simulation right away. So let's come up here to model, geometry, create a sphere, and I give him the size of 20 centimeters for now. Also, a side note, when you use dynamic simulations, try to use real world sizes, right? So don't create a sphere that it's about 10 meters or something. Try to create spheres or balls or objects that matches the real world size. The simulation is way more accurate when you use real world sizes. And a sphere of about 20 centimeters, it's not too big, it's not too small. So we have one sphere here. Now we need 9 more copies of this sphere to have 10 individuals. So how we do that? So you can press Control C on a PC and it pops up this window, clone current item. You can also go to item, clone current item. It does the same thing. So let's bring in 9 clones in. And now you can see that we have 10 individual spheres. Now we need to position those randomly in the space. So I tried different ways how I can clone, and the clones should be distributed randomly in space. I didn't get it. Maybe if some one of you know a tool or a plugin or a workflow, how we can create clones and distribute them randomly in space, please let me know in the comments. It's really appreciated because now what I have to do is I have to move the spheres manually to position them randomly in space. And it's a step that it's, how to say, it's relaxing maybe, but it's maybe not the best way to do that. So if someone knows how I can create copies or clones and distribute them randomly in space, that will be awesome, right? But for now, we're doing that way. All right, so we have all the spheres now distributed. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spheres exactly. Perfect. So the next thing that we need is we need a force that brings the sphere back into the center. So how we do that? So we go up here in the item, create a null object and call this force. Right there. Okay. So, and now we set up the simulation. Okay. So on the force, when the force null is selected, we go to the FX tool and click on explosion. You can see that the explosion shows in the viewport right there. And the yellow lines shows you where the force goes. In this example here, the force goes outside, like an explosion, okay? But for this example, we want to have the opposite. So how we set that up? But first, we select all the other spheres right there. And in the FX tab, we go to use the forming body. Click on that once, and then it should be apply a deforming body on every sphere. Okay, to check that, we go to the FX tool again and go to the item properties. And now everything should be loaded into the bullet engine. So we have our 10 spheres and we have our force, which is set to explosion, and the spheres is set to deforming. You can see the type here. You can also select all the spheres and change to a rigid body, right? Or a kinematic body. So they start to reacting when they get hit of something. But for now, we use the forming body, okay? You can also mix these two. You can select some of those spheres and change only those spheres to a rigid body, and then you have soft body and rigid body colliding each other. You can do that as well, but for now everything is the forming body. The force, as I said before, it's now reacting as an explosion. So when we start the simulation now, all the balls will be pushed outways like an explosion. But we want to have the opposite. And this is the strength value here. So just change this value to -1 instead of 1. As you can see that the lines changed a bit, and now it's more an attractor than a force like an explosion. The next step is in the world tab, we have to kill the gravity right there, because we don't want that the sphere falls down. We want just the sphere stays in place and then get attracted by the force. All right, so this is the setup now. So what I do here to see the collision a bit better, we need more geometry. You could do this at the beginning. When you create a sphere, you can add more geometry to it. But for this example, I just go into the model tab, select one sphere and toggle subpatch, right? And as you can see, it's creating more geometry. And in the surface editor here, turn on smooth. And now everything is nice and smooth. Increase the timeline to 250 and press play and see what we have. All right, so this is right away quite cool. You see that the spheres deforming, but they deforming not enough to really get the feeling of this bubbly wobbly feeling, right? So how we can change this? We have to go into the deforming body settings, okay? So we come up back to the FX tool tab, item, and we select all the spheres right there. And as you can see here, we have some settings to define how strong the deforming of the sphere should be. So the first setting here is the collision margin. So when the sphere starts to deform, when they touching each other, and there is a margin of 5 millimeters. So you can see that when they come together and they reach the margin of 5 millimeters, they start to deform. In some cases, you see this margin and you think, well, these spheres didn't touch really and start to deforming. So to avoid that is you can decrease the collision margin. So I decrease this to 1 millimeter. So it's very close, right? You can even go lower with this value. So just 0.5 millimeters to really decrease the gap and the spheres really touching each other before starting to deform. But 1 millimeter is a good value for this kind of shot. When you go closer to exactly the contact point, then probably you need to go lower with this value. The next thing is the linear stiffness. So the linear stiffness is set to 100% now. That means, is it allowed to the polygons and the vertices to get bent? Okay, so, and 100 stiffness is near to rigid. It's deforming because it's a deforming body, but it feels like rigid. If I start the simulation again, you can see that the sphere's deforming, but not that much, okay? So they feels like it's rigid. So we want to bring it down, this value, to allow the vertices to bend more. Okay, so let's do that. Go to the item properties of the bullet engine, select all the spheres, and we bring the linear stiffness down to, let's say, 30%. And let's see what's happened. Okay, so I move this over here, press play. And now you can see that the spheres deforming more, and it gives them this wobbly wipe. Okay, this is exactly what we want. So what we also can do when we go to the force and we say, okay, we want more force, so they should go into center faster. Okay, but this generates more force how the spheres collide each other. And let's see what we get now. So we get more force, and as you can see now, the deforming is really strong, right? And some of the spheres, as you can see, they are squished together and they don't have enough power to get back to the original shape, so they stay squished. This is an effect maybe you looking for, but if you want to say, I want that the sphere have enough power to try to maintain the shape of the original one, so they squish together and then they try again to push to the original shape, so they don't stay squished like this one here, right? This one here, volume conservation. So how many force we want to give every sphere so they try to maintain the shape, or to, when they get squished, how many force we want to give the sphere to push it back to maintain the original shape. And this value is set to 0 now. This is why some spheres are squished and stay squished. Okay, so what happened when we say 100%? So we give every sphere the possibility to 100% force to go back as fast as possible to the original shape. So they squish and then they start to push again to the original shape. Okay, let's check if the values is set it for every sphere. So make sure you, when you want to change globally the values, that you select every sphere and then change the value. You can change the value for each individual sphere. When it's just selected, we can say just this sphere 6 has a volume conservation of 20%. We can do that. And as you can see, the sphere 7 is still at 100%. So you can drive individual the values for every sphere, right? But for now, we set everything to 100%. So every sphere should be squished, and then they start to push because they become the force of 100% to maintain the original shape. So let's see what we have. Press play. So they get squished. And as you can see now, they push each other and maintain the shape again. So they push together, but they maintain the shape. What we lose now here is the wobbly effect. And now comes the part where we start to playing around with the settings, right? So let's bring this back to 10 maybe. So allows more bendiness, but still maintain the volume conservation. Let's see what we get now. So they bend more, but they push again and maintain the original shape. But the push region here, where they squish together, maintains this squishy effect. And I think this is a very good value setting. So let's create a new camera here. Let's create a match viewport perspective, create a new camera and call this shot cam. We go to the perspective mode and change camera view shot cam. So we are in the shot cam, and I tend to switch at this state to the next layout where I have two windows, right? Here I can change the top to right, front, back views and stuff like that. And here I have my shot cam view. All right, so we select the shot cam and we go into the properties and we change the resolution that we want for the render. Let's say 1280 by 1280, which is square. Okay, you can use whatever resolution you like. For Instagram, 4:3 is common, or square as well. Or you can go widescreen, whatever you like. But for this shot, we go to square and we change the focus type to 65 millimeters right there. And when we press play now, we can see that the bubbles comes in quite nicely. So now we are happy with the simulation. We are happy with the shot of the camera. So now how we texture those, or how we create for every sphere a separate color. Let's see. So if you see, when I change the color here, every sphere gets blue color, or every sphere picks up this color because it's just one material. So how we can tell that every sphere has an individual color? And for that, we have to jump right into the edit node graph. We have the principled B as the F shader model. And now what we need is we need an instance info. The instance info tells we have 10 individual spheres, so every sphere is an instance, okay? And we can drive with the fixed random color or the index ID which color goes on which sphere. But for now, we just use a gradient. We use the gradient, there we go. And we'll pick up this fixed random position into the input of the gradient right there. And we'll plug that into the color. So now what's happened is that every sphere gets black because the gradient is black. Okay, so we go into the gradient. As you can see, we have just one constant, which is black. I want to choose a special color palette gradient from Dithorams, and these color palettes from Dithorams are very well balanced. It's so nice to looking, so pleasing to looking at these color palettes. I can show you one of them, right? You can see this color palette here from Dithorams, and it's his color palette looks so pleasing to watch, especially on product shots where you probably have a cafe machine, right? And every cafe machine has one of those colors, and in combination, the shot looks just gorgeous because this color palette is so well balanced and so well um, organized. It's just cool. I like it. I like the D2 color palette. Okay, so with this D2 color palette open, I can go into the first dot here, which is black now, and I can click on the color and I pick from screen. Okay, and now I can pick the first color. As you can see, the first color gets into the scene. So we click into the gradient, create a second knot, click on the color, pick from screen, and we pick up the second color right there. And as you can see now, we have this soft gradient. But when we change the knots to step and step, we can see that we have this reddish tone and this orange tone. So let's apply the other colors as well. So pick from screen and we choose the next color right there. Change this to step. Create another knot. Select pick from screen. Select the other color right there. And change this knot as well to step, and then one color more, pick from screen and choose the last color right there and change that to step. Distribute knots. Okay, so as you can see, every color is represented in our spheres. And how cool is that? So now here comes a request for LightWave. What if we bring in here a new tab that allows us to load in gradients directly into this gradient ramp, right? So one button, click, bring in gradient, and we can load in this gradient with one click in here. That will be great. So now we have to do it manually, but maybe in the future we have a button here, load gradient. That will be awesome, right? So here we have set up the colors, we have our sphere, we have our simulation, and now let's jump right into lighting. So let's jump right into light and go to the light distance light type and just kill this, right? And then we select the environment light, go to the properties and kill the use global and time dependent. So now the screen goes black. Create a texture environment and we choose a texture environment here. Set to spherical, go to load image. So now we're loading in an HDRI that comes with the Grayscale Gorilla Plus library, and there is a Creative Space HDRI pack, and I like this Showroom 2. There we go. All right, so the HDRI is in our scene, and as you can see, we have a very nice lit HDRI scene. So now we don't want to see the HDRI in the background. So go to backdrop and click on use background color, which is black. But we still have the reflection of the HDRI in our scene right there. So let's go into the surface editor when we are here, and let's crank up the roughness a bit more. Right there, and we can add subs of scattering if you like. It's creating a very cool effect. So I choose the subsurface scattering, but the subsurface scattering is set to white. So to have subsurface scattering for every color, we have to go inside the node graph and we have to plug that in the subsurface scattering color. So now it picks up the same color and then it's creating this subsurface scattering effect. Gorgeous. You can see this highlight here. So how we can avoid to have these burned out highlights. And there is a good trick to get rid of this burned out highlights. And this is in the processing tab here. There is a tone map. And in the tone map, we have 4 types, right? It's Reinhardt, linear, Reinhardt filmic, ACES filmic. And when you say, let's bake the ACES filmic tone mapping, which is more a lot, it's not the ACES workflow. This is an ACES filmic post-process that mimics the ACES tone color space filter. And when you use this, the image, the render looks way more pleasing because you don't have these burned out highlights. But it's baked into your render, right? If you want to use the ACES workflow, don't use any kind of this tone maps. Just leave as it is, right? With this burnt highlights, and export the animation or the render out as an EXR, and then you can use the convert color spaces. But for now, we use this ACES filmic tone map. As I said before, it's just a LOT. It's just a lot, and it will be baked right into your render. And as you can see that the highlight is no longer burned out, and the color looks much more pleasing to watch. Here again the comparison without the ACES tone map and with the ACES tone map, and as you can see that it's more pleasing to watch. What we now can do is, if it's too dark for you, we can increase the power of the HDRI to get a bit brighter. But as you can see, because we use the ACES tone map filtering, even if we go higher with the light intensity, it's not burning out the highlights. All right, so everything is set it up. So because it's cached, we can scroll through the timeline here quite easy. And as you can see, we have this squashy ball, nice color palette from DTRAMS, and with the GPU denoiser, we have a fast preview of our scene. The last step is here. As you can see here, you see this gap between these two, and this is this 1 millimeter. Okay, so to avoid this gap here where the spheres colliding each other, you have to decrease this collision margin, which was in the item properties, this collision margin here. Now it's set to 1 millimeter, and this is exactly this 1 millimeter. So in this case, I would reduce this value to, let's say, 0.3 or 0.4 millimeters to just push this gap in a little bit more, so it's not that big visible. So that is the end of the tutorial. I hope you like this tutorial, and if you want to have more tutorials like that, please let me know in the comments. And as always, please like, comment, and subscribe. I hope it was helpful for you. See you next time, and bye everybody.